For all of human history, spacecraft have been primitive, confining vessels with limited crews, reliant on chemical rockets, and struggling against a vast hostile space. But the coming decades promise to transform space travel capabilities unlike anything before. Advanced spacecraft driven by nuclear fusion, equipped with artificial gravity, and assisted by fleets of support craft and infrastructure could finally make deep space exploration into our solar system practical. Let's look at some exciting tech set to enable our first journeys as a species beyond Mars. Fusion rockets for faster travel, 2 minutes. Future craft will harness immense speed from compact nuclear fusion drives, propelling huge vessels far faster than today's chemical rockets. Their virtually limitless fuel minimizes the need to launch expensive mass from Earth. Powerful plasma thrusters for course adjustments save weight over liquid fuels too. Combined with gravimetric drives surfing space-time itself, trips to the outer planets may one day take mere weeks instead of years. Swarms of high-speed microprobes deployed en route can scout ahead or gather vital data across sprawling regions no single craft could explore alone. Artificial gravity and radiation shielding, 2 minutes. Protecting vulnerable human biology far from Earth is critical for extended deep space missions. Rotating crew compartments can generate artificial gravity, ensuring healthy bone density and muscle mass. Layers of water tanks and supermaterials like graphene soak up harmful cosmic rays and solar radiation. Onboard quantum computers model radiation exposure down to organs and cells, optimizing shielding and prescribing personal medical treatments as needed. Nutrient-dense, 3D printed food and closed-loop air and water recycling sustain life too. Support infrastructure, 2 minutes. Even the most advanced craft can't operate fully autonomously across cosmic distances from Earth. An enabling support architecture is critical, like self-assembling energy, fuel and supply stations positioned around strategic planetary orbits utilizing local resources. Here, backup vessels can rendezvous via hyperloops and beam propulsion shuttles to transfer personnel, restock provisions and handle repairs. A distributed deep space internet bridging countless nodes creates stable communications. And mass drivers around moons fling resources everywhere from off-world asteroid mining. From liftoff to landing, next-gen spacefarers rely on surrounding infrastructure. Modular and adaptive design, 1-minute spacecraft heading beyond the moon for years can't anticipate every challenge. So next-gen vessels feature modular sections which can detach and self-navigate to recreate environments as complex as miniature space stations en route. Labs for everything from botany to materials, science help analyze unexpected discoveries and even produce necessary solutions like 3D printed radiation shield parts or transmitter repairs. Reconfigurable adaptive interiors alter room shapes, equipment positions and more, morphing layouts to suit changing mission needs over time. Extreme environment mobility suits, 1 minute. Even with the most advanced motherships, exploring strange new worlds ultimately requires boots on the ground. Future spacesuits will enable real mobile missions, able to withstand everything from 500 DGF heat on one side and 200 degreeing on the other while scaling Martian mountain cliffs. Microgravity thrusters keep explorers balanced astride asteroids. Powerful exoskeleton frames grant superhuman strength to construct bases single-handedly. And integrated nanodrones gather microscopic terrain details no astronaut could see firsthand. Come havoc or hardship from undiscovered local conditions, revolutionary EVA suits empower deep space pioneers to press onward. Conclusion, 1 minute. The age of advanced spacecraft promises to open our solar system's secrets like never before. With technology set to revolutionize access, the epic of pioneering deep space voyages beyond imagination awaits just over the horizon. Fusion drives, artificial gravity, modular adaptive designs and flexible infrastructure will enable journeys no crew today could endure. What astounding revelations or alien Earths await beneath the suns of distant stars? Our probes and generation ships may soon trek into the void on this ultimate quest of high adventure to find out. The final frontier continues to call us.